What if everything you've experienced your entire life has just been a useful fiction? Through a mathematical model and evolutionary game theory simulations, Donald Hoffman claims he has proof that there is a precisely 0% chance you and me perceive base reality, or the world as it actually is. Let's explore this rabbit hole we call reality, brought to you by evolution. UC Irvine cognitive scientist Donald Hoffman has a few earth-shattering theories, but in this video series, we'll focus on his foundational fitness beats truth theorem. According to evolution by natural selection, an organism that sees reality as it is will never be more fit than an organism of equal complexity that sees none of reality but is just tuned to fitness. Never. We'll fully unpack this concept in a bit. First, it's helpful to briefly lay some groundwork on human vision and the brain. 1/3 of the cortex is devoted to vision. 120 million photoreceptors and 200 million interneurons in the eye relay information to upwards of 50 billion neurons and 10 trillion synapses in the brain. Specifically, you should know that our minds aren't merely observing, but rather reconstructing the images and colors we see. A few examples to illustrate the point. First, which table looks longer? Almost everyone says the table on the left, but their measurements are actually identical. These shepherd tables are a geometrical illusion. Our brains improperly decode them according to heuristics for 3D objects. Second, cover the center of the screen with your hand and notice how the movement seems to accelerate. Now, cover the two sides of the screen with your hands and you'll perceive slower motion. Amazingly, the speed is fixed throughout, and your mind, in real time, reconstructs the momentum. These are Purvey/Lotto blocks, and the top block appears to be darker. But hover your finger on the line between gray and white, and you'll see that they are literally the same shade of gray. This corn-sweet illusion highlights that you're actively reconstructing the shade of gray, and by now you'll concede your perceptions are prone to errors. You manufacture all the colors that you see. Light has no inherent color. According to physics, it only has frequency and wavelength. The visible colors we see represent a narrow band of the electromagnetic spectrum, between roughly 400 and 700 nanometers, and we conceive these colors in our minds. Take these two squares. Which looks lighter and closer to yellow? They look distinct, but they're actually exactly the same. We can remove the surrounding area and your visual system reevaluates, more accurately rendering the lower box's color. It's tough for this to sink in because the visual system pulls this off seamlessly in moment-to-moment existence. But your brain is constantly modeling the stimuli from its environment and crafting a phenomenal experience, transforming colorless wavelengths of light into the qualia of color. If you're enjoying this video, please like and subscribe. Let's return to the fitness beats truth theorem and classify the competitors in Hoffman's simulations. Our definition of fitness is provided by the legendary John Maynard Smith as a measure of the probability of transferring genes, and therefore characteristics, into the next generation. Colloquially, higher fitness means better at surviving and reproducing. There are many definitions of truth. Therein, it can be best described as veridical, the degree to which an experience, perception, or interpretation accurately represents reality. For simulation buffs, you may consider truth base reality. It will be useful now to quickly examine a distinctive feature of biological resources and fitness from mathematics. A monotonic function is when x, in this case fitness, increases linearly or logarithmically with y, here being valuable resources for an organism. This is opposed to its converse, non-monotonic functions, where fitness may peak for a certain number of resources and decrease in either direction. This would be a Gaussian normal distribution, aka a bell curve. In nature, monotonic fitness functions are uncommon, the vast majority of fitness functions will be non-monotonic. Say with water, too little and a person dies of thirst. Too much and one drowns in a flood. Most resources are non-monotonic for organisms. Oxygen, for instance, needs to be concentrated in air between 19.5% and 23.5% for humans. Outside that range can be deadly. Organisms have an inherent need to maintain homeostasis. So most fitness functions in the upcoming model are non-monotonic, though Hoffman does include monotonic functions in the simulations for good measure. Now, onto Hoffman's evolutionary simulations demonstrating fitness beats truth. My intention is to provide a simplified yet faithful portrayal of his framework. It's rather complex and requires some advanced math to fully appreciate the model. I'm quickly displaying the relevant slides from a presentation by Hoffman's mathematician, Prakash, if you wish to pause and review. And if you want every ounce of minutia, their research paper is linked below as well. So 2 strategies, truth versus fitness only, are playing a repeated territory selection game. There is a shared environment, a real-world W, which contains some number of territories, each with a resource or resources that correspond to numerical fitness values. Now, a fitness function, which aims to make choices that optimize for fitness, has a few inputs. The observer-independent world, W, the organisms, O, their possible states, S, say how hungry or thirsty the organisms are, and their actions, A. To keep things simple, we'll assume just one world, one type of organism, one state, and the only actions are selecting territories, which occur one at a time, alternating who goes first. We'll also assume just one resource, water. As we discussed earlier, water is pragmatically a non-monotonic bell curve. There's a Goldilocks zone that's preferred over barren desert or the deep ocean. Each territory in the world directly corresponds to a specific fitness value. The higher the F value, the better. The next feature of the model is the most vital for comprehension. The 2 strategies, truth and fitness only, receive the same inputs. These are sensory states, X. Just like all biological life, the simulation provides them access to the world through their perceptions. Let's cover a concrete example to show how each territory corresponds to a sensory state, X. Let's say it's the first round of the game and truth goes first. Assume the 2 competitors don't have any information yet. To keep it simple, we'll consider only 2 territories. The resource is water, and imagine that the sensory state for each territory is a soil sample, which each competitor gets to feel in their hands. To reiterate, the competitors have 0 knowledge about the world and fitness values. They receive that information after they've selected the territories. At this point, they only have access to these 2 soil samples. Let's say one soil sample is 25% moisture and the other is 75% moisture. The truth strategy attempts to build models for territories that most accurately reflect the sensory information. At first, these will be quite crude. With a soil sample of, say, 25% moisture, this could reflect a wide variety of territories, some closer to deserts, but others that are moderately wet. So through repeated instances of the game, the truth strategy tries to faithfully model the veridical conditions of the territories using Bayes' theorem. Rather than building a model of the territories as they seem to be, the fitness-only strategy uses Bayes' theorem over time to map sensory states directly to fitness values. Okay, we're going to return to the differences in these 2 strategies in a minute. But first, a brief overview of Bayes' theorem. Bayes' theorem, a pillar of probability theory and statistics, is a method for updating probabilities given prior evidence. Bayesian inference is fairly standard in perceptual science. One example. Let's say you're the subject of an experiment listening to sound tones. After a bunch of trials, the average tone is 1,000 milliseconds long. That's your expectation, or in Bayesian terminology, your prior. Then you hear a tone that's approximately half that length, 600 milliseconds. That's reality. But you end up combining past experiences with the present sensory experience, and your estimate of the length is 800 milliseconds, your estimate or posterior. That's an extreme example, but cuts to the point. Over many iterations, your prediction errors get smaller and smaller, getting closer to the truth. Now, back to the two competitors. Let's clearly lay out their strategies, which both follow a conventional perceptual science design of PDA, perceive, decide, act. Each receives the same sensory states, and each sensory state corresponds to a territory. Using Bayes' formula, the truth strategy estimates the territories based on these given sensory states, plus the previous sensory states and associated territories from earlier rounds of the game. It essentially reconstructs the most accurate representation of the world, grounded by weighted evidence. Based on this quote-unquote true model of the world, it then compares the fitness values of the territories. Finally, it chooses the territory based on the sensory state that yields the highest fitness. Thus, its choice is first filtered through its Bayesian map estimate of the world. Then, it consults historical fitness values. Now for the fitness-only strategy. Using Bayes' formula, fitness-only computes the expected fitness payoff based on the given sensory states, plus the previous sensory states and associated fitness values from earlier rounds of the game. Fitness-only weights these fitness values by their previous distributions, then chooses the territory based on the sensory state that yields the highest fitness. Thus, it makes no attempt to accurately model the objective states of the world. It merely models directly for fitness. These two strategies are pit against one another in millions of Monte Carlo simulations. Evolution is emulated through a replicator equation, genetic algorithms, and birth-death dynamics as a result of the Moran process. On top of these simulations, the formal math by Chetan Prakash also independently comes to the same conclusion, that fitness beats truth. For an infinitely large class of generically chosen worlds, for generically chosen probabilities of states on the worlds, and for generically chosen fitness functions, an organism that accurately estimates reality is never, in an infinite class of evolutionary games, more fit than an organism of equal complexity that does not estimate objective reality, but is instead tuned to the relevant fitness functions. This deserves extra emphasis. You have both the millions of evolutionary simulations and the formal mathematics proving that mapping for truth is always inferior to mapping for fitness. Dr. Jordan Peterson.
And so we live in a landscape of relevance. And to me, that's an absolutely mind-boggling idea, because that is way different than living in a landscape of facts. It is not the same thing, even a little bit. But because the classic scientific idea is something like you perceive a universe of facts and derive conclusions and act. It's like, no, you don't. You perceive a landscape of pre-categorized relevance that's dependent on your ethic. Jesus, it's so peculiar that.
Perception is not about seeing truth. It's about having kids. Let's bring this down to earth with an example from a relatively simple early stage round. Assume truth and fitness only have been playing for a few rounds, alternating turns for who goes first. Assume they are tied and that they have access to the same information. Both organisms aim to maximize fitness by implementing their respective strategies. The truth strategy is building an increasingly accurate model of the world. In this example, truth is differentiating between varying levels of moisture from soil samples. We can make these qualitative labels for clarity: very dry, dry, wet, and very wet. If provided samples within these categories, truth would then estimate the real-world territories and compare the fitness values from earlier rounds to determine the best choice. Fitness only, on the other hand, skips this veridical modeling and relays directly to its own constructed labels, which more closely match up with fitness values. Let's pit these two against each other with a concrete example. Suppose the two sensory states provided this round to truth and fitness only are 45% moisture and 70% moisture. Truth consults its priors, grouping 45% moisture into the dry bucket and 70% moisture into the wet bucket. Recall that the fitness values for water are a non-monotonic bell curve. So based on earlier rounds, the fitness expectations between 45% moisture and 70% moisture seem equal. Truth would randomly select one. And this is where fitness only gains its edge. If fitness only were to go first, it would consult its priors, grouping 45% moisture into the great bucket and 70% moisture into the good bucket. Fitness only is irrelevant to the actual states of the territories. Fitness only always selects the best choice here, picking 45% and gaining the higher fitness value. Truth would be left with the suboptimal territory. You can see how, after just a handful of rounds and sensory states, fitness only emerges with an advantage over the truth. In fact, the likelihood of fitness only dominating truth exceeds 50% as soon as the sensorium has more than 5 elements, and rises monotonically to 100% as the size of the sensorium grows towards infinity. Effectively, the math shows that after about 30 states, it's all over for the truth. Fitness wins. Natural selection drives true perceptions to swift extinction. An implication is that if you were to trace evolution back 3.5 billion years to Luca, our last universal common ancestor, then the vertical world would be lost within a few dozen sensory states, and never to be recovered, even by us. If we don't see objective reality as it is, then what are we perceiving? Hoffman hypothesizes our conscious experience is a species-specific user interface, like a desktop computer, which itself is a simplified, useful tool that hides most of its underlying reality, such as its programming code and electronic hardware. This is Hoffman's interface theory of perception, which we will examine someday. For now, we'll stick to the fitness beats truth theorem. And you likely have several objections to this conclusion. I plan to tackle those and provide further commentary in the second video of this series, which you can find in the upper left corner. Oh, and please subscribe.